Right, so in this video, I'm going to provide a systematic way of solving our second order circuits here. So what I have here is just a very simple series circuit with my two energy storing components, the inductor and the capacitor here. And I'm not going to solve this circuit per se, but then what I want to do is just provide a framework of how we ought to tackle a circuit, circuits this size or circuits even larger. So the key here is to find what we want to look for is we want to look for the initial and final values of something here. So hopefully that sounds somewhat familiar from our previous chapter, as the former chapter kind of was a build up to what we have now. So the very first step we want to look at is what is the behavior of the inductor or the current that's going through the inductor and the voltage across the capacitor when time is less than 0 here. So this is what I mean when I say time is equal to 0 minus. Essentially, what we're saying here is this is the time. This is the time before any sort of switch activity is happening, or time less than 0. Now, the next thing we want to do is, okay, so once we have that, we want to know what happens at when time is greater than 0 or after some sort of switch activity. It can be a switch close, switch open, etc. So we want to look for those next. Next, we want to look for what's happening in what you call the transient period. So the transient period is going to be the period from initial to final condition. So whether it's from high to low or low to high, that's called the transient period. And in the transient period, we're looking for di dt when time is greater than 0, and also dv dt when time is also greater than 0 as well. So hopefully you can see a common theme here. Also note that when it comes to di dt and dv dt, the instantaneous value of these is going to be for di dt, it's going to be the voltage going across the inductor divided by the inductance itself. And then for dv dt, it's going to be the current going through the capacitor divided by the capacitance, like so. And the final step that we need to account for is, well, what happens to the current that's going through the inductor when time goes to infinity, and also what's the voltage across the capacitor when time goes to infinity, and we call that steady state, or what happens at a long period of time.